Okay, so to start this unit, we are going to go back to parabolas and quadratics for a minute, and we're going to learn how to graph them. So just a reminder, the quadratic function, we have our general form, where we have an x squared term, an x term, and a constant term. And a, b, and c just represent numbers or constants. So remember, we have the graph of a quadratic is that U shape. You could go up, open upwards with the arrows pointing up, or it can open down with the arrows pointing down. And the graph's shape is called a parabola. Is a parabola. So we're going to go through all these key features of parabolas and how to determine them from an equation, and then how to use these features to sketch a graph of the parabola. So I'm going to use the equation y equals 2x squared minus x minus 3 as an example. So as we go through and define these, we'll find these features with this example here. So the first feature of a parabola is direction of opening, just which way it's opening. Just said the same thing twice in a row. But basically that just means which way the arrows are pointing. If they're opening up, the arrows point up. If it opens down, the arrows point down. And this direction of opening is based on the sign, whether it's positive or negative, of a, of that coefficient in front of x squared. And if we have a positive a, then our graph opens up. Looks like that. And if it's a negative a, the graph opens down. Okay, so for our example over here, and I'm going to draw a divider here. So for here, our a value is 2, which is positive. So that means our parabola will open up. Okay, so we know that our graph should have a general shape like this. The two arrows should be pointing up when we have our graph sketched. Okay, so that's direction of opening. Then we have the axis of symmetry. The axis of symmetry is an imaginary line that splits our parabola in half, and your parabola is symmetric about that line. So if you were to fold your parabola over on that line, it would line up because it's symmetric, hence axis of symmetry. So the axis of symmetry is a vertical line that cuts the parabola in half. And since it's a vertical line, that means it has the equation of x equals, always x equals, and to get the number that x equals for our vertical line, it'll be the opposite of b over 2a. So whatever your a and b are. So for our example over here, we have a is 2, and in this case our b is negative 1. So to get our axis of symmetry, it would be x equals the opposite of b over 2a. So just use parentheses when you plug stuff in to start, and now we can simplify. So minus a negative 1 would be a positive 1 over 2 times 2, which is 4. So our axis of symmetry would be the vertical line x equals 1/4. So if I go to my graph, x equals 1/4, I can draw a little dashed line. It'll be about here. X equals 1/4. So that should be where the middle of our parabola is. Okay, then we have the vertex. The vertex is either the highest or lowest point, just depending on which way the parabola opens. Highest or lowest point. It is a point, so it has an x and a y value. So that just means if it opens up, then we have the lowest point right there, and if it opens down, then it's the highest point right there. So the vertex is in the middle of the parabola, and so that means it goes through our axis of symmetry, and the axis of symmetry is an x value, right? It's x equals. So when we have our vertex, the x value of your vertex is always going to be the same as your axis of symmetry, so the opposite of b over 2a. So same as axis of symmetry. And then for the y value, well, we have an equation up here, over here, that will tell us what y is if we know x. And we'll know x because that'll be whatever the axis of symmetry is. So to get the y value, we just plug in that x value into our equation and solve for y. So we're doing f of that axis of symmetry. Plug axis of symmetry into the equation and solve for y. So we'll do the example over here. So for the vertex, so we know our x value, same as the axis of symmetry, so our x value will be 1/4. To get the y value now, we just plug in 1/4 into our equation up here for x. So we'll have 2 and then in parentheses 1 divided by 4, close the parentheses squared, minus 1 divided by 4 in parentheses minus 3. And you can use your calculator, type this into your calculator exactly as is, making sure you use parentheses and that your squared is on the outside of the parentheses. And for the purposes of graphing, it's easier to use decimals just because it's easier to kind of see on the graph where that is. So when you type this in your calculator, you get negative about 3.125. Or if you hit the math enter button, it would be negative 25/8. So either way, whatever method, the fraction or the decimal, makes it easier for you to plot that point. But this is our vertex. And so if we go to our graph, so we have our 1/4, that's where that axis of symmetry is, and then negative 3.125. So just past negative 3, so about right here would be our vertex. Okay, so slowly but surely we're adding stuff to our graph, or our parabola here, to sketch the graph. Okay, now last things are the intercepts. So the y-intercept is where the graph crosses the y-axis, or where x equals 0. So you just plug in 0 for x and solve for y. Or since we have, when it's in this general form, when you plug in 0 for x, this term will become 0, and this term will become 0, and you'll just be left with whatever c is. So a little shortcut, the y-intercept will just be 0, c, whatever the c value is. So if we have our example over here, 0, and our y value would be c, which is negative 3. So we go to our graph on the y-axis, the point 0, negative 3. It's right there, close to the vertex. Okay, and then finally our x-intercept. So our roots, our zeros, our solutions, again, lots of names for the same thing. This is where y equals 0, where it crosses the x-axis. And we have learned a bunch of different ways to solve. We can solve by factoring if we're able to factor. Or you can use the quadratic formula, which will always work. Okay, so if we go over here to do it with our example, so we have 2x squared minus x minus 3. So there's no greatest common factor we can take out. Our a is 2, b is negative 1, c is negative 3. So you can choose if you want to try to see if you can solve by factoring, or if you just want to go right into using the quadratic formula. Either one is fine. I'm going to try to solve by factoring. So we do a times c, that gives us negative 6. Then I list all my factors of negative 6, and I'm looking for factors that will add to give me negative 1, give me the b value. So that would be 2 and negative 3. So I'm going to rewrite my middle term, my x term there. 2x minus 3x. Constant stays the same. Squared term stays the same. Split our problem in half. Greatest common factor on both sides. So I can take a 2x out here. Remember, when it's exactly the same, you have to have a 1 there. You have to have that placeholder. Always copy that sign down. Negative 3x divided by negative 3 is a positive x, and negative 3 divided by negative 3, positive 1. So now our parentheses are the same. X plus 1 is one of our factors, and 2x minus 3 is our other factor. So to solve, now we just take our factors, set them both equal to 0, and solve for x. So we'll have x equals negative 1, add 3, divide by 2, x equals 3/2. Okay, so solving, that's the same. You still have to remember how to factor or use the quadratic formula. So I'll plot these up here on my graph, negative 1 and 3/2. So negative 1 and 3/2. Now you just want to check, because whenever you plot your x-intercepts, they should be equal distance from this axis of symmetry, right? Because we have our axis of symmetry splitting our parabola in half. So those x-intercepts should be symmetric. So if you had one x-intercept that was all the way over here and one that was here, that would not be symmetric, and you want to double check. Okay, and then we just connect the dots we have, and we know our parabola has to open up, so we got to make sure our arrows are going up. Go through all the points that we know, and beautiful. All right, so it's just being able to find all those different aspects and graph them as you go. Okay, so we'll do another example together here. So negative x squared minus 8x minus 7. So I'm going to write down a is negative 1, b is negative 8, c is negative 7. So direction of opening, remember, has to deal with our a value. And so in this case, our a value is negative, so that means our graph is going to open down. Then our axis of symmetry, we use x equals opposite of b over 2a. It's always x equals. And so here our b is negative 8, so it'll be opposite, negative, and then the negative 8 in parentheses, divided by 2 times negative 1. Give us 8 over negative 2, or x equals negative 4. So I'm going to graph that vertical line here, just a dashed line at x equals negative 4. Then my vertex, so remember the x value is always the same as your axis of symmetry. And to get the y value, we just have to plug in that x value back into our equation for x. Okay, so I'll have be careful with parentheses. That negative out in front, then a negative 4 in parentheses squared on the outside, minus 8, negative 4 in parentheses, minus 7. Type that in your calculator exactly as it is, and you get 9. So our vertex is negative 4, 9. Then the y-intercept, this is where x equals 0. And so in this case, when we plug in 0 for x, we'll just be left with our c term. This will cancel, that'll cancel, it'll become 0. So it'll be 0, negative 7 for our intercept, y-intercept. And then finally for the x-intercepts, we just have to solve. So again, we can solve by factoring or quadratic formula, whatever way you want. We have our, so negative x squared minus 8x minus 7. So a is negative 1, b is negative 8, c is negative 7. Again, we can solve either way we want. And so when we do a times c, that gives us a positive 7. So we need factors of positive 7 that will add to give us negative 8, and that would be negative 1, negative 7. Then we split our problem in half and do greatest common factor. Always carry down the signs that are out in front there. Bring down that middle sign. So I have x plus 1 as one of my factors, and negative x minus 7 as a second factor. Set them both equal to 0, solve for x. And I get x equals negative 1 and x equals negative 7. So I plot those up here, negative 1, negative 7. Then I'm basically just going to connect my dots. I know we need our parabola to open down, So you want to make sure that's what happens here. Alright, it doesn't have to be perfect. You just want to make sure it's opening the right way and that it's hitting all the points that you have plotted there. Okay, so now there's just a quick check question and do the same thing. Find all those properties of the parabola and use them to sketch a graph. And then some self-assessment questions, and bring any questions you have to the Google Meet.